All right, so we're going to talk about parallel line problems using quadratic equations today. So once again, the steps for the introductory level parallel line problems, you've got to identify the types of angles that you're given, identify the relationship between those angles, whether they're congruent or supplementary, use that relationship to write an equation, and solve for x. We're still going to be using those same skills today, but we're going to be doing it in the context of quadratic equations. So what is a quadratic equation? Quadratic equation is an equation with an x squared term in it, and you're going to get two possible values for x. Mathematically, the two values that you get for x work every time. Because we're working in a geometry context, you will have situations where one or both of those answers is not actually reasonable for the context that you're looking at. So that's going to be part of what we're talking about today. We'll look at an example problem. In this example problem, we've got angle EHB is x squared plus 2x degrees, and angle DKF is 20x minus 23 degrees. These are same side exterior angles, which are supplementary. So the equation is going to be x squared plus 2x plus 20x minus 23 equals 180. We can combine like terms to simplify a bit and turn it into x squared plus 22x minus 23 equals 180. There's a few different strategies you can use for solving quadratic equations. This video is going to focus specifically on the strategy of the quadratic formula. So here's our example problem again. We had this equation. In the quadratic formula, we need an equation to be in the form ax squared plus bx plus c equals 0. And when it does, we can find x with the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is a great big bowl of alphabet soup right there. So that's a formula that if you're going to rely on it, you need to either memorize it or have it written down somewhere that you can find it very easily. But once you do memorize it, it's a really useful formula to have in your pocket. So we've got this equation. For the quadratic formula, we're going to need to make one side equal 0. So we subtract 180 from both sides to turn it into x squared plus 22x minus 203 equals 0. This is now in the form of ax squared plus bx plus c equals 0. So we can identify a is 1, because if there's no coefficient written there, it's a 1. B is 22, and C is negative 203. Negative because it's being subtracted. So we just said A is 1, B is 22, C is negative 203. The quadratic formula was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can plug a, b, and c into this formula to make it look like x equals negative 22 plus or minus the square root of 22 squared minus 4 times 1 times negative 203 over 2 times 1. If b had been a negative number, when we make it negative b, it's actually going to change to positive. And we always want to use parentheses when plugging in the b squared and our a and c there, just to make sure that our negatives are being handled correctly. So we've got this equation, x equals negative 22 plus or minus the square root of 22 squared minus 4 times 1 times negative 203 all over 2 times 1. We can follow PEMDAS now to evaluate this. So first step, in the square root, we can square 22 and turn it into 484. We can multiply minus 4 times 1 times negative 203 to get plus 812. And we can multiply 2 by 1 to get 2. Then inside the square root, we can add 484 and 812 to get 1,296. We can then take the square root of that number. So we now have x equals negative 22 plus or minus 36 over 2. That's actually two equations meshed together there. So we can split it into x equals negative 22 plus 36 over 2, or x equals negative 22 minus 36 over 2. Simplifying each of those, we get x equals 7 or x equals negative 29. So we've just gotten two answers for x equals 7 or x equals negative 29. We need to plug each of them in for those angle measures to check for reasonableness. So if x equals 7, plugging it into x squared plus 2x gets us 63 degrees for EHB. Plugging it into 20x minus 23 gets us 117 degrees for DKF. And this is fine. Both of those are totally reasonable answers to get for the angles in this picture. If we plug in negative 29 for x, then EHB is 783 degrees and DKF is negative 603 degrees. Now, these do add to 180, as our original equation told us, but we can't have angles that are above 180 degrees or below 0. So the individual values for these two angles are no good. We need to throw this out. So our final answer here is just x equals 7. X equals 29, mathematically fine, but in the real life geometry situation that we're looking at is no good. So quick formula of what we did here. We need to get the equation into the form ax squared plus bx plus c equals 0. We need to identify a, b, and c in our equation. We need to plug it into the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, either memorize that or keep it written somewhere that you can find it easily. Then follow PEMDAS to simplify and find two values for x. Use those two values of x to calculate angle measures to check for reasonableness. And then you might have one reasonable answer, you might have two reasonable answers. Whichever one or ones are reasonable, you can give as the final answer. So it is possible to get two reasonable answers for x here, even though we didn't in this example. It is also possible that one of them is going to fail. I mentioned that there are other strategies you can use. Sometimes you can solve a quadratic equation by factoring. The one that we did in this video can be solved by factoring. You can look up videos on this strategy if you're interested in it. The downsides to this strategy, one, it doesn't necessarily work every time, and two, it does require a stronger number sense in order to figure out how to factor that polynomial. And then there's another strategy called completing the square. Completing the square does work every time and has the advantage of not requiring you to memorize the quadratic formula, but it does require a bit more rearranging to get to completing the square. I'll link a video about that strategy below.